Every time you enter a confined space of any kind, whether it's a sewer vault, a storage bin, a pipeline, a grain silo, a manhole, trench, or vat, there is the very real danger of a hazardous atmosphere existing inside the space. Experts tell us that 9 out of 10 confined space fatalities are due to hazardous atmospheres. So, before you enter any confined space, it is essential that the atmosphere be thoroughly tested for hazards and that those hazards are properly dealt with. A confined space is defined as any area that is large enough for someone to enter and perform work, has limited ways of getting in and out, and is not designed for continuous occupancy. Any space that meets this description must be approached cautiously, with the assumption that dangers exist inside. Additionally, confined spaces that have hazardous atmospheres could contain material that could engulf or entrap entrants, have converging walls or floors that could entrap an entrant, or contain other safety risks such as unguarded machinery, exposed live wires, or heat stress, require a confined space entry permit. Remember, potentially hazardous confined spaces exist in virtually every industry. This program is intended to help you learn the importance of atmospheric testing in confined spaces, to learn how to identify atmospheric hazards, to understand instrument calibration and testing procedures, and to learn how to deal with atmospheric hazards you may encounter. Let's face it, at first, a confined space is really a big unknown. After all, most atmospheric hazards are invisible to the naked eye, and most are odorless as well. So a quick glance or sniff will tell you next to nothing about a confined space's atmosphere. And if you don't know exactly what you'll be breathing in once you're inside a confined space, you could very easily and very quickly find yourself in a perilous, life-threatening situation. When it comes to atmospheric hazards, we're basically looking for 3 dangers: unsafe oxygen levels, flammable gases, and toxic vapors. All 3 of these potential dangers require specialized equipment and procedures to detect. And that's where atmospheric testing comes in. The first rule of atmospheric testing may seem obvious to you, but it is simply this: before anyone enters the space for any reason, the atmosphere inside the space must be tested using a calibrated direct reading instrument. Never enter a confined space that has not been properly tested for atmospheric hazards. And a reminder about entry, whether testing or to perform work. Whether you are the entrant or the attendant, remember to utilize constant communication and follow your facility's permit entry plan as detailed on the confined space entry permit. This permit, located at the entry of the confined space, will identify which atmospheric tests are needed and is a guide for the testing process. The permit lists the equipment and procedures to use in testing and notes the conditions required for safe entry. The person conducting the atmospheric test must notate the results of these tests on the confined space entry permit. There are 2 distinct purposes for atmospheric testing: evaluation of the hazards of the space and verification that acceptable conditions exist for entry into the space. Evaluation testing determines what chemical hazards are present or may become present in the space's atmosphere. Subsequently, evaluation testing also identifies what steps must be followed and what conditions met to ensure that atmospheric conditions are safe for workers. Evaluation testing determines what procedures, like line breaking or lockout-tagout, will be used to isolate the space from external dangers, what methods will be used to ventilate the space, how the atmosphere will be cleaned or purged, what work and safety procedures will be employed, and what PPE or special tools will be required.
All of these details will be noted on the confined space entry permit and reviewed by a technically qualified professional, such as an OSHA consultant, safety engineer, or other competent person.
Using permit-specified equipment, verification testing ensures that those conditions identified in evaluation testing are properly addressed. Verification testing is done to make sure that any chemical hazards that may be present are within the levels necessary for safe entry and meet the conditions specified on the entry permit. Results of verification testing are also recorded on the permit. After exiting a confined space, always retest all areas of the space before re-entering, whether it's after lunch, after a break, or any other time away from the site. Verification testing is a continual, ongoing process throughout the life of the job until completion of all work has been performed in the space. Always retest the space before re-entering. Before testing the atmosphere in the confined space, you need to know that your testing equipment is accurate. It needs to be calibrated. Instruments that aren't calibrated properly can become inaccurate over time and lead to serious incidents. So instrument calibration is vital to worker safety. The only way to guarantee that an instrument will detect gas accurately is to test it with a known concentration of gas. This exposure will show whether the sensors are responding accurately and whether the alarms are functioning properly. The two methods of verifying instrument accuracy are the bump test and full calibration, both of which use a known concentration of gas. The bump test calls for the testing of the instrument in a clean, fresh air environment using a known concentration of gas. The instrument should be zeroed for greater accuracy and set to the appropriate tolerance range for the gas being used. If the instrument is working correctly, the alarm will sound upon exposure to the gas. If the instrument does not respond correctly or as expected, full calibration is necessary. Bump tests should be performed before each day's use and initial entry by a trained professional. Full calibration involves adjusting the instrument's reading to coincide with a certified concentration of test gas. Any adjustments should be made by a qualified professional and follow the manufacturer's recommended calibration frequency and procedure. Keep an updated record of each instrument's calibration to meet safety standard requirements, as the best way for an employer to verify calibration is through documentation. Before opening up the confined space, perform one last check of your equipment. Make sure the batteries are fresh and working. Make sure there are no damages to or obstructions in the hoses. Be sure the equipment has been calibrated and ensure that response and alarm settings are functioning. And make sure that probes and hoses are long enough to test the entire space. It's always a good idea to do a quick check for corrosive potential within the space, although the proprietor of the space should provide you with accurate information on possible corrosives and what is required for cleaning the space. Corrosives can damage your probe, so use caution. Be careful as well to keep probes out of any liquids found within the space, as they could damage the sensors and eliminate the effectiveness of the probe. Initial tests of oxygen levels, flammable gases, and toxic vapors must be performed from outside the space. Air samples should be taken through a pick hole or a small opening. Stand upwind of the location to prevent contaminants from being blown into your face. And remember, high concentrations of toxins and flammable gases can accumulate under covers and around openings. If ventilation is being used, turn the system off for pre-entry tests. After pre-entry tests are complete, turn the system back on and retest the air. This helps determine the effectiveness of the ventilation system. This information must be noted on the entry permit. Gases and vapors in a confined space tend to stratify. In other words, they find their own levels, floating in layers within the space. Heavier gases like hydrogen sulfide accumulate at the bottom, whereas lighter gases like methane collect at the top. Carbon monoxide has roughly the same density as air and will be found in the mid-level. Check levels every 4 feet and on all sides to make sure the space is free from harmful gases. If an alarm sounds, the space must be fully purged, ventilated, and retested before entry of any kind. Once the pre-entry test is complete, you're ready to open up the space and retest. Remember, we're basically looking for 3 hazards: unsafe oxygen levels, flammable or combustible gases, and toxic vapors. And we test for these in that order. First, oxygen levels. Second, flammable and combustible gases. And third, toxic vapors. The test for oxygen levels is performed first because most combustible gas meters are oxygen dependent and will not provide reliable readings in an oxygen deficient atmosphere. The normal oxygen level in fresh air is around 21%. If the oxygen level drops below 19.5%, the atmosphere is considered oxygen deficient, which can lead to a loss of judgment, loss of coordination, fatigue, vomiting, unconsciousness, and ultimately death. You may be surprised to learn that by the time you realize you're suffering from oxygen deficiency, it will most likely be too late. You won't have the judgment, coordination, or strength to save yourself. If the oxygen level rises above 23.5%, we call this oxygen enriched. This can lead to an extreme fire hazard. In other words, it can create a combustible atmosphere. Changes in oxygen levels within a confined space can be caused by chemical reactions, such as rusting metals, microbial activity, hot work being performed in the space, or the displacement of oxygen by other gases. Combustible gases create a threat of fire or explosion. These gases are often odorless and invisible, and if the concentration of a flammable gas is high enough, even a tiny spark can cause a catastrophic explosion. Flammable gases are second in the testing order because the threat of fire or explosion is more immediate and more life-threatening than exposure to toxic vapors. A flammable gas's lower flammable level, or LFL, is the amount required for an explosion to occur in normal air. If the level of a combustible gas exceeds 10% of its LFL, or if a combustible dust meets or exceeds its LFL, the atmosphere is considered hazardous and must be purged and ventilated. Be sure to test for flammable gases throughout the space, covering horizontal areas as well. This is necessary because small pockets of flammable gas can ignite if surrounded by non-flammable gas. As with flammable gases, toxic gases and vapors are often invisible and odorless. Common toxic vapors are methane, hydrogen sulfide, nitrogen, and carbon monoxide. A few inhalations of any of these dangerous gases could kill you. Each toxic gas has its own permissible exposure limit, or PEL, expressed in parts per million. The PEL levels determine the allowable time weighted average, the short-term exposure limit, and the instrument ceiling limit. Be sure that the alarms in your instrument are set to go off at the appropriate level for the gases you might expect to encounter. As always, check the entry permit to see what toxins could be present in the space and determine the PELs. Exposure to excessive levels of toxic gas can cause serious illness and even death. While pre-entry testing is of paramount importance, it isn't enough. Your health and even your life depend on ensuring that the atmosphere remains safe over the duration of the entry operation. Often, work performed inside the space, or even just outside of the entry space, can change the atmospheric conditions. So, as stated earlier, continuous atmospheric testing is essential. Immediately after entering the space, repeat all 3 tests. 1 for oxygen levels, 2 for combustible or flammable gases, and 3 for toxic vapors and gases. Check the top, middle, and bottom levels, and cover any areas you couldn't reach from outside the space during pre-entry testing.
Be especially thorough in areas where contaminants might leak into the space or accumulate. If you must go into an untested area, unless it is designated as IDLH, wear a supplied air respirator until tests are complete. After entry, either periodic retesting or continuous monitoring is needed. The entry permit will indicate which of these is necessary. Continuous monitoring is essential if you'll be performing work that can create a hazardous atmospheric condition inside the space. This includes scraping, scaling, painting, sealing, using solvents, and doing hot work. The space must also be retested following breaks, or if work will be continued by a new shift of workers. If test results at any stage of the entry operation show the atmosphere to be unsafe, entry into the space must be prohibited or discontinued until conditions are brought into acceptable parameters. Perhaps more importantly, a confined space that is already occupied by an entrant or entrants must be evacuated immediately if tests show the atmosphere has become hazardous by an unsafe increase or decrease in oxygen levels, an increase in flammable gases, or an increase in toxic concentrations above acceptable levels. Only after the space has been evacuated, the source of the problem identified and addressed, and the atmosphere retested and deemed safe, should entrants re-enter the space. Major culprits behind confined space injuries and death are complacency, familiarity, a false sense of security, and negligence. Don't let any of these issues compromise your safety or that of your coworkers. You may be able to go several hours or even days without food or water, but you can't go more than a minute or two without clean air. So it is essential that the air inside a confined space is breathable, and that means thorough testing before entering a confined space and retesting or continuous monitoring throughout the duration of an operation within the space. Always perform every test required by the confined space entry permit. Test the atmosphere for unsafe oxygen levels, flammable gases, and toxic vapors, in that order. Maintain and calibrate your testing equipment daily. Remember, your life and the lives of your coworkers depend on it. And finally, know your facility's proper procedures for evacuating the space should a hazardous condition arise, and know how to contact emergency rescue services as required. When it comes to potentially hazardous atmospheres, you can't trust your nose or your eyes. Your testing equipment and procedures are your last line of defense against elements that you cannot see, taste, or smell. Never speed through the testing process or cut corners. Lastly, remember this: most confined space deaths that result from exposure to lethal atmospheric conditions could have been prevented with proper training and the implementation of safe confined space entry procedures. Ignorance and complacency are deadly ingredients when it comes to workplace safety. Be safe, be aware, and don't become a fatality statistic.